class, welcome to Unit 3, Day 16. In this lesson, students will be able to apply L'Hopital's rule to evaluate limits of the indeterminate forms 0 over 0 or infinity over infinity. Now, recall that if you divide a number into 0 into a number, you get what's called undefined, because it's not possible to divide 0 into a number. However, 0 over 0 is indeterminate, and also infinity over infinity. Since we don't know what infinity is, we can't say that this infinity and the top infinity are the same infinities. So we don't know what this value may be approaching. Same goes with 0 over 0. 0 over 0 may be a number, but we don't know what it actually is, so we call them indeterminate. Now, go ahead and pause this video now and take 1 minute to do the do now. Now, in the beginning of this class, in Unit 1, we talked about taking limits of functions by doing some sort of algebraic manipulation here. The first step you needed to do was direct substitute the -3 into each of the x's. And when you do that, you get 0 on the top and you get 0 on the bottom. Now notice, I'm not saying that this is equal to 0 over 0. You cannot put that on an AP exam, otherwise you may lose some credit. So instead, what I'm saying is that if I substitute, the numerator will become 0, and so will the denominator. And we know that that is an indeterminate. So I can write 0 over 0 without equals, and that's okay. But you guys may have remembered that if we have indeterminate, we can simply do some algebraic techniques. In this case, you may have noticed that you can just factor the numerator and the denominator. And you get this new expression. You also may have noticed that x plus 3 and x plus 3 are on the top and the bottom. Therefore, you divide out, and now you have a new expression, which is x minus 2. And once you have this, you can direct substitute -3 into the x, and you get -5. And this is the limit for this limit expression. Now, what this is trying to tell me, what you should get out of this is that 0 over 0 doesn't always mean that you're going to get does not exist for a limit. That's not always true. In this example, 0 over 0 actually gave us a limit value of -5. So it's pretty unclear what 0 over 0 is. We call it indeterminate, but we know that 0 over 0 may hold a value. And to do that, you have to take limits of functions that give you 0 over 0 and do something with the limit so that you can get a limit value. Now, not all the time will 0 over 0 give you a limit value. And in this lesson, we're going to be seeing some examples where 0 over 0 actually gives us values, just like in the do now. Now, this lesson is based off L'Hopital's rule. So here's L'Hopital's rule. Take about a minute to read through L'Hopital's rule. As you're reading through the rule, highlight, underline any keywords, any key points that you may find useful in this rule. After 1 minute, I'm going to go ahead and break down the rule so that you guys are able to understand what this is saying. Now, you may have read L'Hopital's rule, and you're probably wondering to yourself, I have no idea what it says. Well, I'm going to go ahead and break it down for you guys. So, L'Hopital's rule says that if the limit, I'm going to read from here, if the limit of f of x over g of x as x approaches c produces an indeterminate form, then you can do this step here. Now, if you observe this step, f of x, f prime of x, g of x, g prime of x, they're just derivatives. So the first step in using L'Hopital's rule is to first apply direct substitution. And when you apply direct substitution, you get one of 3 things that occur. The first is you may get a limit, and you're done. You don't need to use L'Hopital's rule. The second thing that might occur is you may get a number divided by 0, which gives you either infinity or negative infinity, depending whether the number is positive or negative. And that is undefined. But you're also done because you can't find the limit. It's undefined. Now, if you get an indeterminate form of 0 over 0 or infinity over infinity, where each infinity can be a plus or a minus, then you have to use L'Hopital's rule. So let me show you what L'Hopital's rule says. The first step is always apply direct substitution. The second step, if you noticed, we're taking the derivatives of f and g individually. This is not the quotient rule. So don't do quotient rule just because you see a fraction. So taking the derivative, taking the derivative at the top and the bottom will give you a new limit expression. The limit as x approaches c of the derivative of f, which is f prime, and derivative g, which is g prime, in a fraction form. Now, that is the first step of L'Hopital's rule. Once you identified whether you have indeterminate form, the third step is apply direct substitution, just like the way you would have in the do now. And one of three things can occur. You can get a limit value and you're done. Or you can get undefined and you're done. However, if you get another indeterminate form, you would have to repeat steps 1, 2, 3 until you get a limit value of L or undefined, if needed. One of the teachers I used to work with says he calls this fourth step rinse and repeat. So sometimes you may have to apply L'Hopital's rule more than once. Now, these are the key points of L'Hopital's rule. Let's go ahead and apply these 4 key points into our first example. So here is the do now example that we had above. I'm going to go ahead and do the do now once more, but this time I'm going to be using L'Hopital's rule. So the first step is apply direct substitution. And we already know it's going to be 0 and 0 on the top and the bottom, which gives us an indeterminate form of 0 over 0. Okay, so this tells me that I have to use L'Hopital's rule. I'm not going to use factoring, rationalization, or simplification here. So in order for me to use L'Hopital's rule, I have to tell whoever is reading my paper that I'm going to use L'Hopital's rule. It's actually a requirement in the AP if it's a free response. So by L'Hopital's rule, we have, well, what do? After step 1, we differentiate. So the limit as x approaches -3 of the derivative of the numerator, the derivative of x squared plus x minus 6 is just 2x plus 1 over the derivative denominator, which is 1. Once I have step 2 done, I go to step 3 and apply direct substitution. So in this case, I don't need to write limit again. So I'm just going to direct substitute -3, and I get 2 times a -3 plus 1 over 1, which is -5 over 1, and that is -5, which confirms the limit value from above. So now notice, I computed the same limit as above using L'Hopital's rule. I did not need to use any algebra. So L'Hopital's rule is a cool technique for us to avoid algebraic techniques in finding the limits of indeterminate forms. But you could only use L'Hopital's rule if you get 0 over 0 or infinity over infinity. Now, there are some other indeterminate forms, but just because you get indeterminate forms that are not 0 over 0 or infinity, you can directly apply L'Hopital's rule. That'll be tomorrow's lesson. Let me go ahead and show one more example of L'Hopital's rule using a different expression. So here we have the limit as x approaches 0 of e to the 2x minus 1 over x. Now the first step is to direct substitute. So applying direct substitution, I get e to the 2 times 0 minus 1, which is equal to e to the 0 minus 1, which is 1 minus 1. And that becomes 0. Now in the denominator, I get simply just 0. So I get 0 over 0, and that is indeterminate. So because I got 0 over 0, now I need to use L'Hopital's rule. And the second step to L'Hopital's rule is differentiate. The numerator, differentiate. Excuse the handwriting, that's an R, differentiate the numerator and the denominator. And make sure you let the reader know that you're going to use L'Hopital's rule. So by L'Hopital's rule, we have the limit as x approaches 0 of the derivative of e to the 2x, which is e to the 2x times 2. The derivative of negative 1 is a 0, so no need to write minus 0. The derivative of x is 1. Now, step 3, apply direct substitution. So, using direct substitution, I get e to the 2 times 0 times 2 over 1, which is 1 times 2 over 1, which is 2. And I see that I get the limit as x approaches 0 of this expression is equal to 2. Now, what this says is that 0 over 0 doesn't always imply a non-existing limit. So just because you have 0 over 0, you shouldn't tie that with d and e. That's not always going to be true. In this case, and also in the previous case, 0 over 0 actually gave us a number. In this example, 0 over 0 gave us 2. In the previous example, it gave us negative 5. So the only way to work with 0 over 0 is to do something with the limit algebraically or apply L'Hopital's rule until you get either an existing limit or a non-existent limit. Now in some cases, you may need to use L'Hopital's rule 2 times or more. So here we have another example. The limit as x approaches infinity of 5x squared plus 3x minus 1 over 4x squared plus 5. Let's go ahead and apply the first step, which is direct substitution. Now in this example, you can't really direct substitute infinity, so I'm going to write direct substitution in quotations. Just pretend that you are going to substitute infinity into x squared. Well, that becomes a large infinity plus another large infinity minus 1. Well, that's just approaching an infinity. And in the bottom, well, if you were to substitute infinity into x squared, that's just 4 times an infinity, which is a larger infinity, plus 5, and that is just infinity. And we have the indeterminate form, infinity over infinity. So what does that tell us to do? Apply L'Hopital's rule. So differentiate. So tell the reader what you're going to do. By L'Hopital's rule, we have, now take the derivative of this numerator and denominator and make sure that you're not using quotient rule. So the limit as x approaches infinity of 10x plus 3 over 8x. And again, because I'm dealing with infinity, I'm going to go ahead and quotations apply direct substitution. And I noticed that applying infinity into the numerator will give me an infinity, and infinity in the denominator, which is yet again an indeterminate form. So what do we have to do? Repeat steps 1 to 3 if needed. So this is what one of my colleagues likes to call rinse and repeat. So again, apply direct substitution. I'm sorry, apply L'Hopital's rule. By L'Hopital's rule, we have, and take the derivative of the numerator again, which will now be the second derivative. So the derivative of 10x plus 3 is 10 over the derivative of 8x is 8. And in this example, we don't necessarily need to apply the limit or substitute because there isn't an x value to substitute. So the limit as x approaches any number of a constant is just a constant. We can simplify this as 5/4. And here we get, after 2 applications of L'Hopital's rule, the limit of the original expression is actually equal to 5/4. So in this case, infinity over infinity, for this specific example, gave us a limit of 5/4.